Okay, in this class we are going to start differential equation, ordinary differential equation. So first, linear differential equation. So you are all know about what is differential equation. So differential equation is equation. It contains the dependent variable and then derivative of independent variable with respect to dependent variable. So what is linear differential equation? So in short, maybe I can write D. So D is a differential equation. So the general nth order differential equation is of the form a naught into y nth derivative and some constant a1 times y n minus 1th derivative and so on, plus an of x. Okay, we in general, if you take, it's a function of x. Okay, it's a function of x. This a naught, a1, an, these are all function of x are constant into y equal to b of x. So this is a general form of nth order linear differential equation, where this a naught of x, the coefficients a naught of x, a1 of x, etc., an of x are continuous functions of x, are continuous functions of the independent variable x. Okay, where this y power n is nothing but the nth derivative of y with respect to x, that is d n y by dx power. So that is a notation. Now the examples of linear differential equation with any coefficients. For example, if we consider x square into y double dash plus x into y dash plus 5 times y equal to some function of x, maybe you can take e power x. And we call this a variable coefficient because the coefficients are variables x contained. So therefore, this is called the equation with the variable coefficient. Suppose all the coefficients are constant, we call it a constant coefficient. So y double dash plus 3 times y dash plus 6 times y equal to some function of x, maybe you can take 0. So this type of equation is called a differential equation with the variable coefficient. If at least one of the coefficients are variable, then we say the differential is a differential equation with variable coefficients. If all the coefficients are constant, then we call the differential equation is differential equation with the constant coefficient. Okay, but in this session, we are going to study only differential equation with the constant coefficient. Some particular examples of differential equation with variable coefficient we will discuss. Okay. Now, suppose a differential equation not a linear equation, we call it a non-linear equation. Okay. Anyway, in this section, we are going to discuss only for linear differential equation. Now, the next one is homogeneous and then non-homogeneous equation. So when we say a differential equation is a homogeneous equation, equal to the right hand side function is function of x, then we say, so for example, a naught of x into y nth derivative plus a1 of x, the general case, plus etc., plus some an of x into y equal to b of x. So this is a general linear equation. Suppose if the right hand side function b of x is non-zero, then one is called non-homogeneous equation. The equation one is called non-homogeneous equation. Non-homogeneous differential equation or non-homogeneous equation. And second case, suppose the right hand side function is 0 for all x, then one is called homogeneous equation. One is called homogeneous equation. Okay. Now, in the previous case, example 1 is a non-homogeneous equation, example 2 is the homogeneous equation. Okay. Now, what do you mean by general solution? And then what do you mean by particular solution? So, general solution means what? So, definition for general solution. Solution means what? Is a function of x satisfy the given differential equation, that is called the solution. And when we say solution is called the general solution. A solution of nth order differential equation is said to be general solution if it contains n arbitrary constant. Okay, a solution contains, if suppose a solution of a solution of nth order differential equation is said to be general solution. General solution if it contains, the solution contains n arbitrary constants. If it contains n arbitrary constants. For example, the solution may be of the form, suppose if we consider second order equation, then we have to c1 into y1 of x plus c2 times y2 of x. So this y1, sorry, the c1, c2 are constants. Okay. So this is a general solution. The solution contains n arbitrary constant. Such a solution is called a general solution. Now, particular solution means what? The next one is particular solution. So a solution of the nth order differential equation to be a particular solution if it has no arbitrary constant, but it is a solution, but it does not contain any arbitrary constant. Such a solution is called particular solution. Maybe I can simply write it does not have if it has no arbitrary constant. The solution does not contain arbitrary constants. So you write the story in the beginning, okay? So your solution is said to be a particular solution if the solution does not have any arbitrary constant. Now, the next one is what do you mean by initial value problem? So when we say a differential equation is said to be initial value problem. Value problem. So differential equation with some condition. Suppose it is a nth order differential equation, we have a n condition. Okay, some initial condition. That's suppose if you have some nth order differential equation or b of x or something, you have a n differential n initial condition in terms of some point x0 or x0. We have tried what is y of 0, we have tried what is y dash of 0, we have tried y double dash of 0 and so on up to yn minus 1th derivative of 0. So if you have n initial condition with the nth order differential equation, we call the system is called the initial value problem. If you take second order differential equation, you have suppose for example y double dash plus y dash equal to 0. The second order differential equation with the initial condition means we have to take some y of a equal to something and y dash of something equal to some l or something. So we needed two initial conditions for second order differential equation. Now, first we start with the first order differential equation, first degree, and then what are the methods to solve or to find the solution of first order first degree equation. So we know what you mean by order and degree. Okay. So the next thing is methods of solving a first order or first degree polynomial. First order first degree polynomial. So first order means what? The highest derivative is 1. First degree means what? The power of the highest highest derivative is 1. First order first derivative differential equation. What are the methods? So the first method is separation of variables. So first, hereafter we consider a differential equation with uh, this is anything. So either is a differential equation with a constant coefficient or variable coefficient. This is a standard method. Now the first method is method of separation, variable separable. First method is variable separable. Okay, we got to separate the variables x and y, and then you have to integrate. Okay. So, so if you take any first order first degree differential equation, we have to rewrite is of the form dy by dx equal to f of x by some function of y. So that is we have to separate, just to cross multiply, we get a g of y into dy equal to f of x into dx. We got to separate all the y's are one side, all the x are another side. Now we got to integrate both side. So in this side we got to integrate with respect to y. We get integral g of y dy, and this side is we get integral f of x dx. We can add some integrating constant c. So you'll get a solution. For example, if we consider the first order differential equation, dy by dx plus 1 plus y square by 1 plus x square equal to 0. So this is the first order differential equation. Now you can take this number that side, with that term we get minus 1 plus y square by 1 minus 1 plus x square. Okay. Now divide this 1 plus y square this side, we get a dy by 1 plus y square, and this is equal to minus dx by 1 plus x square. Now integrate both side, and below that integration of 1 plus x square is tan inverse of x. Therefore, this side is, so integrate both side. We get, so integration of 1 by 1 plus y square is nothing but tan inverse of y. And then minus, again integration of this is nothing but tan inverse of x plus some constant c. Now we can take everything one side and then keep c one side. Therefore, we get tan inverse of x plus tan inverse of y equal to c. So this is the required solution. Okay. Now we discuss one more problem. But not all the first order differential equation you have to solve using the method of separation. So suppose you can separate the variable, we can solve it. So the next one is tan y into secant square x dx plus tan x secant square y dy equal to 0. Now, how to solve this? We got to separate x and y. So already here this is a x terms, but here we have a tan y. Therefore, we have to divide tan y. And here we have a tan x. Therefore, we have to divide tan x. Therefore, divide tan x. Sorry. Yeah. So we have to divide 1 by tan x into tan y. So maybe call this equation number 1. So therefore 1 becomes, we have to divide both side by 1 by tan x into tan y. So therefore the first term we have a secant square x by tan y cancel, we have tan x into dx. Plus here we have a secant square y by Tan x cancel, we have tan y into dy equal to 0. Now we separate the variables. X are all one term, other terms are y. Now we have to integrate. You can take that side and then integrate, no problem. You can keep everything one side and then integrate. So integrate, what you'll get, integration of secant square x by tan x into dx plus integration of secant square y by tan y into dy. If we integrate, we get some constant c. Now, what is the we know that the integration of tan x is nothing but secant square x. So, if we differentiate the denominator, we get the numerator. Okay, so that is we know the formula. So that is suppose the integration of f dash of x by f of x into dx. That is, we differentiate the denominator, we get a numerator. We can simply write log of modulus of f of x or f of x, log of f of x. That is the integration. And we know that integration of tan x is secant square. So therefore, the derivative of the denominator is the numerator. Therefore, this is nothing but log of tan x. And here also, since the derivative of the tan y is secant square y, therefore, this is nothing but log of tan y. So since everything is log, we can adjust the constant is log c. It's not an issue because everything is anyway constant. Okay, we can adjust. We can write into log c. Now use that log property, log of a plus log of b is nothing but log ab, and therefore we get log of tan x into tan y equal to log c. You can take exponential both side. We get the log cancel, and we get tan x into tan y is c. Tan x into tan y equal to c. So this is the required solution. Okay. So this is the first method, separation of variables. Now suppose a differential equation, the right hand side is of the form, the next form. The next form. So the differential equations of form dy by dx equal to is a function of ax plus by. Then in that case, we have to put z equal to ax plus by. Now, and then apply the separation of variable. Okay, and apply separation of variable. Okay. Now, for example, if you consider the differential equations of the form dy by dx equal to 4x plus y plus 1 whole square. Okay, so it's very difficult to, even if we expand this using the a plus b plus c whole square formula, it's very difficult to split uh, the variables. So better we can call this is z. So we call z is the number, the term 4x plus y plus 1. So put z equal to this. So therefore, you got, since the equation in terms of y and x, now we have to change into z into x in terms of z and x. Therefore, you have to differentiate this with respect to z. With respect to x, we get dz by dx, the right hand side. Left hand side, we have this. If you differentiate with respect to x, we get 4 plus what is the derivative of y? Dy by dx. And then what is the derivative of 1? 0. Therefore, we can replace dy by dx by dz by dx minus 4. Okay, therefore, the first equation becomes, the equation 1 becomes dy by dx can be written as dz by dx minus 4 equal to, and this is called z square because we call z equal to 4x plus y plus 1 whole square. Now we can separate the variables. Now we can take the 4 that side. We have a dz by dx equal to z square plus 4. Now divide this z square by 4 this side, we get a dz by z square plus 4, and this is equal to dx. Now we separate the variables. Now integrate. Now this is actually integration of is of the form 1 by x square plus a square into dx. So the integration is of the form this. So this is nothing but 1 by 2, 1 by a, otherwise 1 by a tan inverse of x by a. So that is the integration formula. So here, if we integrate both sides, we get tan 1 by 2, because here a is 2, therefore 1 by 2 tan inverse of z by 2 equal to what is the integration of dx is x plus some constant c. Now replace z value. Z is 4x plus y plus 1. Therefore, you can multiply 2 that side. We have tan inverse of 4x plus y plus 1 by 2 equal to 2 times x plus c. So if you want to y, you can multiply tan both sides. The tan inverse cancel. We can write the solution. Otherwise, you can stop it here. So suppose if you want, you can apply tan both sides. We get a 4x plus y plus 1 by 2 equal to tan of, multiply 2 inside, we get 2x plus 2c. If you want, you can multiply these two also. Therefore, we get 4x plus y plus 1 equal to 2 times tan 2c. So this is the required solution. So therefore, the right hand side is of the form function of ax plus b format. Then we got to call that is z, and then you have to change the differential equation into in terms of z and dx, and then apply the separation variable. Finally, we got to replace the z value. You will get a solution. Okay. And maybe we'll discuss one more problem in this method. So dy by dx equal to secant of x plus y. Now again, it's very difficult to apply separation variable directly. So we have to change. We call that x plus y is z. Okay. So put z equal to x plus y. Now what is dz by dx? We got to differentiate both sides with respect to x. We get 1 plus dy by dx. Now therefore the equation 1 becomes dy by dx is nothing but dz by dx minus 1 equal to secant z. Now similarly, we can take the secant z to that side, and then we'll get dz by dx equal to 1 plus secant z. Now we will get dz by 1 plus secant z equal to dx. Now we can integrate, and then we'll get answer. So integrate. So fill it up. Okay. So just integrate, and then you have. So how to integrate this one? So otherwise, just call u equal to 1 plus secant z. Okay. And then what is du? Differentiate this. What is the derivative of secant x? Secant x into I think cosecant x, right? Therefore, you can simplify it. So just you call this number is u, and then you can integrate. Okay. Just reading it. Okay. So this is another form. Now, next we are going to discuss another form. Before that, we are going to discuss what is homogeneous function or homogeneous equation. So, homogeneous function. So, when we say a function is homogeneous function, suppose a function of two variable, that is function of f of x comma y. So, when we this is a homogeneous function, homogeneous function. So, when we say homogeneous function, if we replace x by lambda x, y by lambda y for some lambda, we'll get satisfy that f of lambda x comma lambda y is lambda power some n times f of x comma y. A function satisfies this for some lambda and for some n. Such a function is called a homogeneous function. Okay. Now, suppose the differential equation, the right hand side, the first order differential equation, the right hand side is a homogeneous function. We can write. So, for example, what is the example of homogeneous function? If we take f of x equal to f of x comma y, if at least two variable. So, function of two variable, we can take x square y plus x y square. So this is a homogeneous function because if we take f of lambda x comma lambda y, just replace x by lambda x. Therefore, lambda x whole square into lambda y plus lambda x into lambda y whole square. Therefore, you get a lambda cube both sides. Therefore, you can take lambda cube outside. We get x square y plus x y square. So this is nothing but lambda cube into f of x comma y. Okay, so here 3 is the order, or sometimes called the index. Okay, so this is one example of a homogeneous function. Now, yeah, first order differential equation is said to be homogeneous. Okay, so maybe the state definition. Yeah, first order, yeah, differential equation of first order and first degree. First order and first degree is said to be homogeneous. Okay, don't confuse with this homogeneous and then linear differential equation, the homogeneous equation. Okay, said to be homogeneous if it is can be written as of the form. The first order differential equation can be rewritten in the form, can be put in the form dy by dx equal to function of y by x. Okay. Now we have to solve this type of first order differential equation. Okay. What is the working rule to this? We have to call this y by x is some z or some b. So what is the working rule to solve this type of differential equation? Okay. So first we got to put v equal to that y by x. Therefore, from this, what is y? Y is just cross multiply x, we get v times x. Now differentiate both sides with respect to x. Therefore, if you differentiate y, we get a dy by dx. And here we have to apply uv method. So we have to fix x and then differentiate v, we get dv by dx. Plus you fix v and then differentiate x, we get 1. Okay, now the first, maybe we call this equation is 1. Now the equation 1 becomes just to replace this value dy by dx. Therefore, we get x into dv by dx plus v equal to f of v because we call y by x is v. Now we can split. So we can take this v to that side. We get x into dv by dx equal to f of v minus v. Now we can divide and then we get separate the apply the separation variable. We get a dv by f of v minus v, and this is a dx by x. Okay, just to cross multiply, you will get this one. So now integrate both sides, you will get a solution. If you get integrate both sides, you get dv by f of v minus v, and this side is integral dx by x plus we get constants that 1 by x is nothing but integration of 1 by x log x. Therefore, we can maybe write log x plus. So this is a required solution. And then finally you have to replace v by. So once you find the integration, replace v equal to y into x. And then you get in terms of x and y. Now we solve some problem related to this. So integrate solve y square plus x square into dy by dx equal to xy times dy by dx. So we can take this dy by dx that side and then take dy by dx outside. If we take dy by dx outside, therefore we get x square minus xy, right? And then we have another term y square equal to 0. Okay. Now take everything one side. We get a dy by. Okay, maybe you can change some other color. So now the given differential equation can be written as from this. Therefore, dy by dx equal to minus y square. Otherwise, we can multiply minus to this denominator. We get this thing. So therefore, we get dy by dx equal to y square by x square minus y square can be written as y x by minus y square because already we have minus, so we can adjust the minus. Now we have to write this in the form f of y by x. Okay. So otherwise, anyway, this is a homogeneous function. Okay. So if we substitute a, so this is actually f of x comma y. If you substitute x equal to lambda x, y equal to lambda y, you will get a lambda times f of x comma y. Okay. So now, so we can rewrite this side. So we can y square is the denominator. We can take y square outside. So the first term contains xy. Y square is not there, therefore x by y. Okay, minus 1. We can cancel y square. We get 1 by xy minus 1. So anyway, it's of the form is a function of x by y or y by x anyway. Now, so what is the method? You have to substitute v equal to y times x. And then what is the dv by dx?
Sir, it is
Sorry,
x
sorry,
square
sorry.
minus x square, no, sir?
Oh, sorry, sorry, sorry. So thank you. So not y square. Okay. So this is nothing but xy minus x square. So you can take x square outside. We have a y square by, if you take x square outside, we have a y by x minus 1, right? And this y square by x square can be written as y by x, in the numerator we have y square, y by x whole square divided by y by x minus 1. So anyway, it's a function of y by x. Now put this y by x is v, so put v equal to y by x. Therefore, from this y, what is y? Y is nothing but v times x. Therefore, what is dy by dx equal to v into 1 plus x into dv by dx. Now the given equation, maybe we call this equation is 1. Therefore, 1 becomes, replacing dy by dx is nothing but v plus x into dv by dx in the left hand side. The right hand side we have just v square by v minus 1 because just already we have y by x whole square by y by x minus 1. So just to replace y by x is v, we get this one. So now we can take this v that side and then we get simplified. So therefore x into dv by dx, v square by v minus 1 minus v. So if simplify this, v square minus v into v minus 1 by v square minus v minus 1. So if you multiply v inside v square minus v square, you cancel v by v minus 1. So now separate the variables. So therefore, if you cross multiply this, we get v minus 1 by v into dv equal to dx by x. Okay. Now, if you want, you can simplify this again. 1 minus 1 by v into dv equal to dx by x. Now integrate both sides. If you integrate this, if you actually dv minus 1 by v, anyway, directly you can integrate. So integrate. So we'll get integration of dv is v minus integration of 1 by v is log v, and integration of 1 by x is log x. Okay. Now we can add some constant. If you want, you can take log c because some terms are contains thing. Therefore, we can take the constant is some log c. Okay. Now we can adjust this. Where v equal to take this minus log v that side, we get v equal to again we can take log of this is a product of this because it's dx times c because log a log v log c log a plus this one, therefore we can take this. Okay, now replace the value. So we know that we take v equal to y by x. Therefore, what is vx is nothing but y. Therefore, the right hand side is nothing but log of y into c. On the left hand side, we have y by x. If you want to cancel this log, raise the take the log e both side, we get y into c equal to e power y by x. If you want to y equal to 1 by c times e power y by x. So this is the required solution. Okay. So if the right hand side is a function of y by x, then you call that y by x v, and then the given differential equation you have to rewrite into new differential equation, and then apply the separation of variable. Finally, you have to replace v equal to y by x. You get a solution in terms of x and y. Okay. So this is another method. Now, for general method, now I can write the general first order linear differential equation. What is the solution of that? Okay. So the next one is first order equation. First order linear differential equation. Solution of this one. Okay, suppose if you look at the first order differential equations of form dy by dx plus some p times y equal to q. Okay, so here we have extra the dependent variable y, but in the previous two method we don't have this, right? But anyway, we can rewrite this into this form. Anyway, so suppose the differential equation is of the form this, where this p and q are either functions of x or constants. Okay, so this p or q are either constants or functions of x alone, not functions of y. Okay, functions of x alone. Both the case, this is the solution. What is the solution? Now there is some term. That term is called the integrating factor. Integrating factor of this differential equation we call I of integrating factor is integral e power integral this p, so capital P or small p capital P into dx. So once you find that this is the integrating factor of this first order differential equation, now the solution is I can directly write. Therefore, the solution is y into the integrating factor equal to integration integrating factor times q into dx plus some constant. So that is the solution is y into e power integral p dx equal to integral e power integral p dx into q into dx plus c. So this is a solution of the first order differential equation. So first you have to find the integrating factor and then you have to write this solution. Okay. Now we discuss some example. So this p q either constant or variable. So both the case this is a solution. Okay. This is only for first order differential equations. For first order differential equation, the solution differential equation of the form dy by dx plus p times y equal to q, where p and q are either constant or the functions of x, then this is the solution. Now, exercise. Find the solution of this differential equation dy by dx minus y cot x equal to 2x sin x. So here what is p minus cot x? Okay. So our p of x is here function of x. Therefore, our p of x is nothing but minus cot x. And what is our q of x? 2x sin x. Now, what is the integrating factor? Integrating factor is e power integral p of x into dx. So, it's nothing but e power minus cot x. That is minus integration of what is actually cot x? Cot x is nothing but cos x by sin x into dx. Now, if you differentiate sin x, you will get cos x. Therefore, this is nothing but minus integration of this one is log of sin x. Because the differentiation of the denominator is the numerator. Therefore, the integral value is nothing but log of sin x. Now, this minus you can take the numerator, we get 1 by sin x. E and log cancel, we get 1 by sin x. So, this is an integrating factor. Therefore, the solution is. So, once you can find the integrating factor, you can write the solution. Y into integrating factor is 1 by sin x equal to integrating factor is 1 by sin x into q is 2x sin x into dx plus some constant c. Now we can cancel sin x and then integration of x is x square by 2, 2 to cancel, we have just x square plus c. So this is y by sin x. So if you want y, therefore y equal to x square plus c times sin x. So this is the solution. Okay. Very simple. So first you have to find what is p, what is q, and then find the integrating factor. Directly you have to substitute in this formula, you will get a thing. Now another type of differential equation is Bernoulli's equation. It's also very important equation. Bernoulli's equation. So here the first order differential equation of the form dy by dx plus p times y equal to q times y power n. Okay. Again, this either the p and q are either constant or function of x alone, but the differential equations of the form these, then we call this a Bernoulli equation of order n. So this n is a constant except so n is any constant, but n cannot be equal to 0, cannot be 1. Except 0 and 1, n is anything. Okay, n is 2 or 3 or anything. Okay. So how to solve or how to find the solution of this Bernoulli's equation? Now what is the method? So we have to divide this y power n both the side. Okay. So divide y power n both sides. Therefore we get 1 by y power n in dy by dx plus p by, If you cancel one y, we get y power n minus 1 equal to q. You can take everything to the numerator. This y power n, you can take numerator, you get a y power minus n into dy by dx. Again, you can take this y power n minus 1 numerator, you get a y power 1 minus n. N minus 1 can be 1 minus n into p equal to q. Now, we call this 1 minus y power 1 minus 1, we call some value v. So, let v equal to y power 1 minus n. Now, this equation in terms of y and x. Now, we'll get a new equation in terms of v and x. So what is that? Now what is d? We got to differentiate this equation b. So if we differentiate b with respect to x, we get dv by dx. And this side you get 1 minus n into y power minus n because we got to add power 1, right? Therefore, we got to subtract because we differentiate. And then we got to differentiate y, we get a dy by dx. Okay. Now substitute everything in the first equation number 1. So in the equation number 1 contains this factor. Therefore, we have to divide this 1 minus n. Therefore, 1 by 1 minus n into dv by dx. So the equation 1 becomes this y power minus n dy by dx can be written as dv by dx into 1 by n 1 minus n plus, and we call that is v power y power 1 minus n is nothing but v into p equal to q. So this you can multiply this 1 minus n. N is a constant, okay? Because just so I know, we know that one is not, n is not equal to 1. That's why here. So therefore, we get dv by dx plus 1 minus n times v or p times v equal to q. Now this is our new equation. Sorry, I actually this left hand side also we have to multiply 1 minus n, right? You have to multiply 1 minus n all the side. This is a new equation. Now maybe we call this is some p dash and this is some q dash. So therefore the new equation is the form dv by dx plus p dash times v equal to q dash. Okay, this is a new equation. Now we know the solution. First we got to find the integrating factor. So what is the integrating factor of this new equation? E power integral p dash into dx. So once you find the integrating factor, the solution is not y, v into integrating factor. Because the new equation is in terms of thing. Okay. So, okay, maybe we finish this one. So this is nothing but integration of integrating factor times q dash into dx plus c. So you have to substitute everything. Finally, you have to replace v equal to y power 1 minus n. So you get in terms of solution in terms of x and y. Okay. So maybe we solve some problem in the next class. Now we stop the class. Thank you.